Hello again everybody, welcome back to SimBuild UK, it's Ian here. Now that my FMC video is out of the way and that project is now complete, it's time to move on to the next one, which is this FMC, bleh, I got FMC stuck in my head, MCP from Hispa Panels. I mentioned when I unboxed it that I couldn't see a way of mounting my components. I've thought about this and played with a few ideas. I didn't want their PCB, which is, why I didn't get it, but all their components mount to their PCB. What I've come up with is using the middle plate of the kit. I had to enlarge a few holes to make that happen, but basically I'm going to mount every switch to that plate. It's actually the third plate, this is the middle plate. They layer up like that. So how that works is, obviously switches are fitted to this one. Everything's tightened down, the nuts are on the surface here, and then this plate has large enough holes to go over the nuts. Like that, and then finally the faceplate go on the top. Like that. The way Hispa Panels, if you watch their video, the way they do it, they have the actual PCB mounted way back here with the buttons fitted to it, and then what they have is long, I don't know what they are, like perspex rods that convert your push to the actual button, which is way back here, and I didn't want that at all. Maybe it works, I don't know, I just didn't like that idea. I think this is going to be a much more firmer way of doing it, because button is literally mounted, it's solid all the way through where the button is. And what I've had to come up with for the buttons is my 3D printer has come to the rescue again and printed these little standoffs. And how they work is 12mm tactile switches again, same as what I used on the FMC. This time with a green LED on them instead of white. And what they do is, again, you have to snip the little locating lugs off the bottom. And then they simply push in to my little standoffs like that. And then what I do is, using this Deluxe Materials Rocket Hot, which is their thin penetrating super glue, I would just literally, with a micro nozzle, just drip a few bits in to glue the switch to the standoff. The next task would be to take one of the Hispa Panels buttons, and you'll notice that they haven't painted the sides, so any light coming through the back here is just going to bleed out of the side. So that's the job I've got to do, is sit and paint all the sides of the buttons. I put a little drop of super glue on top of the button, only a small drop, because you don't want it to run and get in the button, and I'm using the slightly thicker super glue for that, Rocket Rapid. It's like a medium super glue. So a drop on there, and then as best I can get the button centered on there like that, and just put that aside to dry. So in Blue Peter style is one I prepared earlier. albeit without the back plate. So what I'm going to do is just now glue this button to the back plate. Hold that for a few seconds. Put a little drop on this side as well. There we go. Okay, and then to fit them, it's simply a case of dropping it through the back. Like that. And then looking from the front, I'm just moving it to make sure that the button is nice and square in the hole on the faceplate. And once I'm happy with it, I would take the thin super glue again and just run it along the back there to glue that standoff in place. I haven't done this one, but it was just showing you an example. And you can see that I have done one just to make sure it all worked okay. And you can see that the button stays with the back plate. And I can easily get to it to solder the pins later on. So that's kind of my thinking behind how I'm going to make the buttons light up and how I'm going to fit them all. I'm waiting for some screens to come in the post, which will slot in here, which I will do on the next part of this video. But that's it for now, and I shall see you in the next segment. I was just sitting here looking after I'd done the last bit of the segment and realised that I've made a colossal fuck up. Where I've got the buttons, a bit above needs to be backlighted, and guess what's covering where the backlight's going to be? A big thick black plate. So I'm going to have to rethink that idea, which will be on the next segment of this video. Bit disappointed with myself, but hey ho, at least I spotted it now rather than later. Here's just a quick demo of the light bleed I was talking about, with the fact that the sides of the buttons are clear. I've just wired up one of the LEDs to try it, and to test my LEDs I'm using this CR2450 battery. It's a 3-volt battery, so I can just touch the wires on it. And there we go, the LED has come on. And you can already see the light bleed coming through the sides. Trying to get a good angle here. If I go and flick the lights out, there you go, that's better. You can see the light leaking out of all four corners of the button. So what I'm now going to do is sit and paint it black, and then we'll try it again and see how much better it looks. Okay, I made some slight advances on the MCP. Originally I wasn't going to go with the dual switch on the front here for the head-in and bank angle. I was just going to put an encoder in there and perhaps use the push button part of the encoder to change the bank angle. But I needed to order some white 7-segment displays from Hispa Panels, because the standard displays that you get are too big for the Hispa Panels MCP. They're basically hidden. These are standard size on the Max board, and they just don't fit behind, and half of the last number is missing behind the panel, so I had to order some slightly smaller ones from Hispa Panels, and plus I wanted white. And while I was on there, I saw this dual switch kit, so I picked up one of them and spent the last half a day or so building it up and getting it working smoothly. It's pretty good. It's kind of a funny design, really. If you look on Hispa Panels website, you can see a video on how it's put together. I just followed along with that. It works on a cog system. There's 2 cogs in here, one there on the rotary switch and one here on the encoder. And as you turn the outside shaft, it turns this aluminium pole, which in turn turns the gear, which turns that gear, which is on the rotary switch. And then down the middle of this hollow aluminium tube is a shaft which connects directly to the encoder. With my displays, because I wanted white, and they are 6-digit displays compared to the 4-digit or two lots of 4 digits, 8-digit displays. What I need to do is, these are going to get mounted right back here, and then I'm going to run wires directly to the pins on the back. And to do that, I've got these Max boards that you can just pull off the, bear with me a sec, there we go, just pull off the displays like that, and because we don't want them, what we want is this part. The next job I've got to do is to desolder these pins, because we want to pass wires through the holes and solder them in. If you use a soldering iron, you'll know about these things, the solder suckers. I absolutely hate them. The idea, if you haven't used one, is to heat the solder with your iron and then quickly put this in place and suck the solder up. And I never seem to have any luck with them. Sometimes they work, sometimes you have to heat the solder up 5 or 6 times to get it to suck up fully. But while I was on Amazon, I came across this, which is a soldering iron and a suction pump all in one unit, and it is fantastic. I think it's 11 quid. It's an absolute bargain. I just thought, for 11 quid I'll give it a go, and if it's rubbish I'll put it in the bin, but I absolutely love it. So to desolder this one, I'll do one side quickly just to show you how easy it is. The only thing I don't like about it is they don't seem to do replacement nozzles or tips, and it's quite a big tip, but even for desoldering these little pins, it just works great. One thing I do find is it gets quite hot up to about here, so you have to keep your hands fairly well up out the way, which you need to anyway because I've got my middle finger on the button. And just literally put it on there and suck. It's normally a job I hate, but it's just so easy with this thing. There we go, 6 pins desoldered. Try and show you how well it's sucked them out. There we go. This is the one I've just done. And you can see that they're absolutely clear, and quite possibly with my fingers and a little wiggle, there we go. One desoldered set of pins. So for £11, I think that's an absolute bargain. It's a Duratool and desoldering tool. I'll put a link at the bottom straight to Amazon for the iron. I mean, it's 40 watt, gets plenty hot enough. Takes a little while to heat up. I normally leave it about 3 or 4 minutes, but plenty hot enough so you don't have to spend too long on the pins, etc. I put this MCP aside for a few days because I ran into that problem with my black boxes covering the writing on the front of the panel where the backlight needs to shine through. I just put it aside for a few days while I tried to think of the best plan while I was getting on with other stuff. And the best I could come up with was to either 3D print some new boxes, just a shorter top on it, just to allow the box to uncover the writing on the front. The only issue with that is I've already glued all the switches in, so what I've come up with is a little jig on my bandsaw. It's just, all it is a piece of timber with a 14mm hole bored in it that I can lay the box in, so the box sits flat on the timber and the switch is in the hole, and then I'm just running it through my bandsaw blade to cut the 5mm off the top of each of the boxes, and then I can fit them in. So that's going to be my next job. When I got the Hispa Panels 7-segment displays, like I said, they're 6-digit, and I was having a lot of trouble figuring out what pin was what on the back. So this isn't a Hispa Panels one, but it's a large one, so it's easier to show you. Obviously, when you turn it over, you've got the rows of pins, and they all do something. I have now figured out what the Hispa Panels pin order is, and this is it. So where I've written front on here, it's looking at it from the number side. So using this big one as an example, these D1, D2, D3, D4, D5 and D6, these represent your digits. So digit 1, digit 2, 3, 4, 5 and 6. That's a 6-digit display. The A, B, C, D, E, F and G represent the segments within a digit. So looking at this one, this top line here is segment A, then it just goes round clockwise. So A, B, C, D is this bottom one, E, F and G is the one across the center. So that's your 7 segments. The last pin that will be on the back is this one here, which is DP, which is your decimal point. Obviously with the MCP I don't need any decimal points, so I'm not going to be wiring up the decimal point. So when I look at my max board, I'm going to be running the wires out of these holes, and on Carl Clark's website I'll link to that in the description. He's got a plan of what these pins are for with regards to wiring it to what digit on your 7-segment display. So my cables will come out of this board. So if we say, for instance, on Carl Clark's plan, I can't remember what it is, but if we said that this one here was display 1, we would then solder a cable on here and run it to the relevant pin, which is display 1, which we can see would be the very first pin on the back from our plan. Then say that they don't run in any particular order. If we said the next pin along was segment G, we would then look at our plan and we know that segment G is first, second, third, fourth pin in. So looking on the back, first, second, third, we would then wire it to that pin there. And you continue like that all the way through, and then when you fire it up, everything should be in order and not a load of gobbledygook like I was getting until I figured out this order, which is different to how this one was wired up. With the displays being 6-digit and on the MCP none of the displays use 6 digits, what I've done here is just jotted down what displays are viewable once they're fitted. So like the course uses 2, 3 and 4 on the 6-digit display, and the first officer's course uses digits 3, 4 and 5. The speed uses digits 2, 3, 4 and 5. The heading uses 2, 3 and 4. Altitude uses 1, 2, 3, 4 and 5, as does the vertical speed. And what I mean by that is there's no need for us to wire up digits that we're not using. So as we know, this is actually a 6-digit display. If I turn this over, and you can see that digits 1 is here and 5 and 6 are here. So we only need to wire up 2, 3 and 4. With the altitude, that is the edge of the display, so we need to use digits 1, 2, 3, 4 and 5, and then 6 is hidden behind here. So when I come to wire these up, I'm not going to worry about wiring on our plan. So say for instance for the altitude, I won't be wiring up digit 6, which is this one here. I'll disregard that pin completely because we don't need it. These max displays can handle 8 digits in total. 4 on this side, 4 on this side. But what we can actually do is wire up any combination of 8 digits that we like. What I mean by that is, if we look over this side, we've got speed, which uses 4 digits, and the course, which uses 3 digits. So we've got 7 digits there. So what I can do is use this board to run the digits for both of those displays. So I can wire up 4 on this side and 3 on this side. So that display board is going to run those two digits. Same if we move along here, we've got the altitude, which uses 5 digits, and we've got the heading, which uses 3 for a combination of 8. So when it comes to wiring that one up, we know that this side handles 4 digits, but we can also pinch 1 digit from this side. So the altitude will be those 4 plus the 1, and then the remaining 3 will be the heading. So that board will do those 2. And I haven't got another board prepared, but the third board is going to be exactly the same wiring as the altitude and the heading, because we've got 5 and 3. So 5 for the vertical speed and 3 for first officer's course. So again, 4 and 1 is 5 for the vertical speed, and the remaining 3 will be wired up to the course. Okay, there's just a quick demo on what I'm doing with the wiring on the back of the MCP. If you've seen my FMC video, it's more or less the same kind of setup. What I've got is one long ground wire linking to the first switch, and then all I'm doing is then linking every switch in turn from there on right across the MCP. So here's where the ground wire comes in, and then from there it links to this switch, to this switch, to this switch, to that switch, and so on, all the way through the MCP. I've prepared this one, but I haven't soldered it yet, purely because I need to be able to take this out to separate the 2 plates. When this is fitted, it's actually glued to the face plate, but then this shaft won't allow the 2 plates to separate, and I need to do that because I'm missing one switch here for the auto throttle. They did send me a switch, but if you saw my unboxing video, you'll see that there was a 3-position switch that I couldn't work out what was for, because there is no 3-position switch. on the MCP. And not only is it 3 position, it's also knackered. So I can't use that at all to the bin. So I've got one on order, so just waiting for that to turn up, and then I can fit that in here. And once I've done that, I can then glue this in place. So that's going to be the ground for the switches. Then I'm going to do, I could have linked the LED grounds into the same loop, but I've decided to run a separate loop for the LED grounds. So once I've finished doing all the switches, I've then got to go back and link all the grounds of the LEDs together. You can see as well that I've gone ahead and run all the 3D printed standoffs through the bandsaw. So they are now clear of any writing on the front here. The only one I've still got to do is this one, which is the first one I glued in where I realised the problem, so I'll probably just trim that off with a Dremel. Just in case you're wondering how I solder my switches up with this link, first thing I do is prepare the next switch. So this is our last wire, so we're going to solder it onto the next in line, which is this one. So first thing is to put a bit of solder on that pin. Then I measure the length of wire, allowing for a little bit of a loop in the wire, don't want it tight. Trim that off, and then the end I just cut off, strip the end off, and strip the end of the cut one. Then I put them together and twist them. Then solder the end of those. Then I trim it a little bit shorter. You need the length to start with to be able to twist them together. If they're too short, you can't twist them. So I solder it and then trim them to length. And then the last step is to join the wire to the pin. And that's it. We're then ready to repeat the process to the next switch ground. As I'm doing this, I'm trying to keep the wiring as neat as possible, because on the back of this panel goes this one, and attached to the face of this will be the LED strip lighting for the backlighting for the MCP. So I'm trying to route my wiring so not to cast any shadows on where the writing's going to be on the front here. Also, if you're wondering why I've missed these pins out, here is because I've bent them over out the way because they're not needed. What they are is these rotary encoders have a built-in push button, which we don't need. So those 2 pins are for the push button part of the encoder. And as we're not using them, I've bent the pins out of the way to remind myself not to wire them up really. Same as we did with the FMC, every so often using my multimeter just to check we've got continuity all the way from the first ground over here to the one we've finished on at the moment. Which we have. So we know that the wiring is good so far. I normally try and check it every couple of switches just to make sure that everything is going good.